Welcome back to Algebra 1, Chapter 7, Section 3 in this book. This is titled Solving Linear Systems by Linear Combinations. Linear systems combination. Now, what does that mean? Remember, a linear system means instead of graphing one line on our piece of graph paper, we did two, and the answer is the ordered pair where they meet. Where do these two lines intersect is considered the answer. And we learned two ways. We learned you can graph it, estimate, substitute it in, and see if it's right. And I told you nobody really does this. Or you can do substitution, which I showed you last time, where you have a beauty contest, solve for a variable, and then substitute it into the other equation, solve that one, substitute it back in the first equation. That's what we learned last time. Now, this combination method, when I first started teaching Algebra 1, I skipped it. Because I thought, why do they need to know another way? It's just too much. Too much for Algebra 1. But then I've taught Algebra 2 for years. And right now we have X and Y. One day we're going to add Z. Don't freak out, it's true. Once you add Z, and you want to find where the lines intersect. So it's like X, Y, and then Z, because it's 3D. You need to know combination. So I've decided you can handle it. So we're going to do it. It's not all that bad. All right. So here are my two lines. And this time, instead of having a beauty contest, what I'm looking for is variables in each one that are equal and opposite. Sort of like, Superman and Lex Luger. Equal and opposite. I know Superman's better, but you get the idea. Alright, so do we have anything like that? 4x, 2x, no. 3y, negative 3y, ding, 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 we have it. If we have something equal and opposite, then we go ahead and write this underneath. 2x minus 3y equals 8. We will also, if something is easily made equal and opposite, and that's why we write it over here first. Sometimes we have to fiddle with it to make it work. Okay, but this one's good. You write this one under that one, you put a plus sign and a line, just like you did in second grade. Now we're going to add them together. 4x plus 2x is 6x. 3y plus a negative 3y, which is minus 3y, is 0. But we're not going to write it down because we want it to go away. We only want one variable, x. We want y to go away. And then 16 plus 8 is 24. Now we solve for x. Y is x not known, it's being multiplied by 6, so we divide by 6. So x equals 4. Now, once we get what x is, we go and we substitute it in right here. 2 times 4 minus 3y equals 8. 2 times 4 is 8. Minus 3y equals 8. Minus 8 minus 8. Negative 3y equals 0. Divide by negative 3, divide by negative 3. Y equals 0. So my ordered pair is 4, 0. Now, one reason why I didn't like teaching it is because you end up doing the substitution anyway. The combination's only for the first half. And then the second reason is sometimes you don't have equal and opposite and you have to mess with it. 3, 4, 5, 2. It doesn't work. So if you have to mess with it, what you do is you multiply to make something equal and opposite. So like I can multiply this equation by 4 and this equation by 3, and then I would have things that are equal and opposite. Or I can multiply this equation by 2 and that one by 5. Either way would work. Let's do the x's, okay? So in math, I'm allowed to do anything I want as long as I do it to both sides of the equals. And what I want to do is multiply by 4. 3 times 4 is 12, 4 times 3x. 4 times 5 is 20y. 6 times 4 is 24. Now I do this one, and I'm going to multiply it times 3. So 3 times negative 4x is negative 12x. 3 times 2 is 6y, and 3 times 5 is 15. So now I add these together. Those go away, these add up, 26y equals 39. And now I would divide both sides by 26. And y equals 39 over 26. Let's cheat and see why this is so weird. Because it ends up being 1.5. I remembered that it was weird, I didn't remember how. Alright, so now I'm going to put it back in one of these. I'm going to put it in that one. So negative 4x plus 2 times 1.5 equals 5. So negative 4x plus 3 equals 5, minus 3 minus 3, negative 4x equals 2, divided by negative 4, divided by negative 4, x equals negative 1/2. So my ordered pair is negative 1/2, 1.5, or 1.5. Now, when it's like this, I don't do this. It's too much. I would just do substitution here. If combination is that big of a pain, I don't do it. Unless there's a z, and then you have to. Alright, here's another one. This one, y is not in the right order. I gotta get x on the other side. So I'm going to do plus 5x to both sides. So now I have 5x plus 2y equals 12. Do I have something equal and opposite? No, but it could very easily be made equal and opposite if I multiply it by negative 1, the whole thing. It'd be negative 5x minus 2y equals negative 12. I write it over here. Negative 5x minus 2y equals negative 12. I put my plus sign, so this is negative 2x, those go away, and this is negative 4. Divide by negative 2, divide by negative 2, x equals 2. And now I put it back in one of them. I think I'm going to put it in that one. 3 times 2 plus 2y equals 8. 6 plus 2y equals 8, minus 6 minus 6, 2y equals 2, divided by 2, divided by 2, y equals 1. So my ordered pair is 2, 1. Doodle-doo. I would do it here, I would do it here. In real life, IRL, I would not do it there. I'd do substitution. Alright, unless they told me to in the instructions. Math is great. See you next time.